Continue today's session with the third question of the third Roman. Find the direct common tangents of the circles. The two circles are given. So we need to find out the direct common tangents of the two circles. Okay. So solution. So given circles are, or let the given circles be, so S x square plus y square plus 22x minus 4y minus 100 equals to 0, and S dash x square plus y square minus 22x plus 4y plus 100 equals to 0. So we don't know the relative position of these two circles, whether the two circles touch each other, intersect each other, or one circle lies completely outside the circle, or one circle lies completely inside the circle. So we don't know exactly, for which we need to find out the relative position of the two circles. Okay, so for which first of all we need to find out their centers and their radii, corresponding radii. So C1 is the center of the first circle. What is the center? So this is minus 11, comma 2. So we have discussed already how to find out the centers of the two circles, centers of the circle. So if plus is there, take the opposite sign, and x quotients half. 22 by 2 is 11. So minus is there. So take a opposite sign. So plus y quotient is 4, half of it. So, and what is the radius of the first circle? X square, g square plus f square. So minus 11 whole square plus f square 2 square minus c is minus of minus plus 100. So 11 square 121, 2 square 4, 121 plus 4, 125 plus 100, root 225, which is 15. Root 225, which is 15. Likewise, let us find out the center of the second circle. So this is 11 comma minus 2. R to be the radius of the second circle. So square root of 11 square 121, 2 square 4 minus 100. So this is 125 minus 100. So root 25, which is 5. So let us find out C1, C2. What is C1, C2? The line joining of the two centers. C1 and C2 are the line joining of the two centers of the circles. So C1, C2 is the distance between them. So x1, y1 and x2, y2, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is equals to 11 minus of minus 7, 11 plus 11 whole square plus minus 2 whole square. This is 11 plus 11, 22 whole square, which is 484 plus 2 minus 2 is plus 4 whole square. 4 square is 16. So root 500. This is approximately equals to 22.36 approximately. So now what is R1 plus R2? R1 plus R2 is 15 plus 5, which is 20. So therefore C1 C2 is equals to C1 C2 is greater than R1 plus R2. So 22.36 is obviously greater than 20. So the relative position of the two circles will be like this. This is one circle and this is another circle. Okay. So this is C1 and this is C2. The relative position of the two circles will be, one circle lies completely outside the circle. The two circles neither touches nor intersect each other. Therefore, how many common tangents are possible? This is one tangent, one common tangent. This is another common tangent. These two common tangents are said to be direct common tangents, which we have to find out. And the transverse common tangents is this as well as this. So we are not required to find out the transverse common tangents. We have to find the direct common tangents. So this is one direct common tangent, and this is another direct common tangent. So this is another direct common. Okay. So this point and this points are the points of contact. So therefore this is R1 and this is how much? This is R2. So this common tangent and the radius are perpendicular to each other. So to find out the direct common tangents, we need to find out what? External center of similitude. What is that? External center of similitude. So the point of intersection of two direct common tangents. Two direct common tangents is external center of similitude. So external center of similitude. So this external center of similitude divides C1, C2 in the ratio. So see here, C1, C2 and C1, C2 and external center of similitude. Let us suppose this be P. Let the point of intersection of direct common tangents is external center of similitude be P. So here P divides C1, C2 in the ratio R1 is to R2 externally. So how do we get this P? P is equals to R1 x2 minus R2 x1 by R1 minus R2, comma R1 y2 minus R2 y1 by R1 minus R2. So this is how we will find out the point of intersection of these two. So what we are going to do is, so this point of intersection we will take into the consideration, and since we are required to find out the direct common tangents, so direct common tangent is a line, so the slope of it, because if you want to find out the equation of any straight line, either 2 points are needed. If 2 points are there, we will go through the process of 2 points form. Y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. That is one formula. Otherwise, if we know the line, the slope of a line, and the point anyway we have. So point we will be getting through the point of intersection this formula. So everything we have, x1, y1, x2, y2, r1, r2, everything we have. All that we need to do is just to substitute in this. Then we will be getting this P. So since we are required to find out the equation of the common tangents, direct common tangents, let us take the slope be m. So we have the slope m and the point. So y minus y1 equals to m into x minus x1. So that line touches both the circles. So what is the condition for the line to be a tangent to the circle? R equals to D. So that R equals to D, R1 if you take, and the line, the perpendicular distance from the center to the line, if you take, equate, then we will get the slope. Since these are the two lines for which we are going to get two m values, two values for m. So and then we will proceed. So after that we will do that. So let us find out the point of intersection of the two direct common tangents. Okay. So that is P is equals to R1 x2 minus R2 x1 by R1 minus R2. Next, R1 by 2 minus R2 Y1 by R1 minus R2. So this is equals to R1 X2. So this is X1, this is Y1, this is X2, this is Y2. This is R1, R2 is the R1 X2 15 into 11, 165 minus R2 X1 5 into minus 11 minus 55. 5 11 are 55. So minus of minus plus 55 by R1 minus R2. 15 minus 5, 10. Comma. R1 Y2. 15 into minus 2. So minus 30 minus R2 Y1. 5 into 2. 5 2s are 10 by R1 minus R2. So 15 minus 5, which is 10. This is equals to 165 plus 5, 170 plus 50, 120, 220. 170 plus 50, 220 by 10, comma. This is minus 40 by 10. So this is equals to 22, comma, minus 4 we get. What is this? This is the value of P. What is this P? P is the point of intersection of two direct common tangents. So how much we get? 22, comma, minus 4. So now, since we are required to find out the direct common tangents after all is a line only. The common tangents, plural sense means two lines we are going to get. Let the line slope be M we will take. Let M be the slope of the required direct common tangents. So let M be the slope of this, and we have point. So the slope of this line is M and point we have. So slope point form. So therefore, the equation of the direct common tangent is, we have a point and the slope. So y minus y1 is equals to m into x minus x1. So that implies y minus, what is x1 y1? This is x1 y1 now, because the line is passing through this point and having the slope m. So y minus y1, so minus 4 is equals to m, that we don't know, which we are going to get it soon. So x minus x1 is 22. So this is equals to y plus 4 is equals to mx minus 22m. Therefore, the line is mx minus y minus 22m minus 4 equals to 0. I just transposed all the LHS term onto RHS. So let us suppose this to be 1. Now, if you see this line, the required common tangents, direct common tangents, clearly touches both the circles. So this line touches this circle and this line touches this circle as well. So what is the condition for a line L equals to 0 to be a tangent to the circle S equals to 0? R equals to D. Radius is equals to radius of any circle, because this line touches both the circles at the same time. So that is why radius of any circle is equals to what is D? D is the perpendicular distance from the circle which we have taken into account. Because if we take this circle, so the perpendicular distance from this center to this line. Or if we want to take this circle, so the perpendicular distance from this center to the line. So since the required direct common tangent direct common tangent touches both the circles, the condition is R equals to D. What is R equals to D? Radius of any circle is equals to, what is D? The perpendicular distance from the center of any circle to the line 1. What is this one? 1 is the direct common tangent. The direct common tangent is this. Okay. So, because this line touches both the circles, therefore any circle can be taken into account. So let the line 1 touches the second circle. Why the second circle I have opted? Because the radius is 5. So the numerical calculation is going to be easier with compared to 15. Okay. So let the line 1 touches the second circle, the s dash equals to 0. So what is the radius of the second circle? 5 is equals to the perpendicular distance from the center. Since the line touches the second circle is what I have taken into account. That's why we have to take the center of the second circle rather than the first circle. Okay. So the perpendicular distance from this center to the line. What is the perpendicular distance? See this. This is the line ax plus by plus c equals to 0. And this is the point Vx1 by 1. So this is D. What is D is equals to? The perpendicular distance from Px1 by 1 to the line. Okay. So that is modulus or length of the perpendicular also we can say. So A in the place of x substitute at point x1 plus B in the place of y substitute point y1 plus c by square root of a square plus b square. This is how we will find the perpendicular distance formula. So for which let us do this now. So perpendicular distance. So m into x value is 11 minus y value is minus 2. Here minus 2 minus 22 m minus 4 by square root of the quotient of x plus square of the quotient of y. So m square plus minus 1 whole square. So that is equals to 5 is equals to 11m minus 22m. So minus 11m. Minus of minus plus 2 minus 4 minus 2 by square root of m square plus 1. That implies cross multiplication if we do 5 into square root of m square plus 1 is equals to modulus of minus if I take in common 11m plus 2. Let us continue. Okay. So let us do squaring on both sides. Squaring on both sides. Then, so this is 5 into square root of m square plus 1 whole square is equals to modulus of minus 11m plus 2 whole square. So this is 5 square is 25 into m square plus 1. This square and root will be cancelled. Minus square is plus only. So this is 11m plus 2 whole square. This is a plus b whole square. a square, so 121 m square, 11 m whole square, plus b square, 2 square 4, plus 2ab, 2 2s are 4 into 11, 44 m. This is equals to 25 m square plus 25, 121 m square plus 4 plus 44 m. This is equals to 121 m square minus 25. 121 minus 25 is 96 m square plus 44 m. 25. This if you transpose onto that side, minus 25 plus 4, which is minus 21 equals to 0. Now, this is a quadratic equation. Quadratic equation means we are going to get two values for m. What is m? The slope. So, since there exists two lines for which we are going to have two values for m. Okay? Let us try to solve this quadratic equation now. So, this is 96 into 21 is 2016. So, we have to find out the factors. Let us do the factorization. So, 44. So, 96 into minus 21 is minus 2016. So, 44 should come. That is plus 72 into, this is 96 into minus 21. 72 into minus 28 is also minus 2016. And 72 minus 28 is 44. So, 96m square plus 72m minus 28m minus 21 equals to 0. So, let us try to solve this. So, this is equals to, take 24m in common. 24 fours, 96. So 4m plus 24 3 72 minus, take 7 in common in both of them. 7 4s are 28. So minus I have taken into common. Therefore, this minus will become plus. 7 3s are 21 equals to 0. This is equals to, so this is equals to, take 4m plus 3 in common, then 24m minus 7 equals to 0 is what we are getting. Therefore, 4m plus 3 equals to 0 from, or 24m minus 0. So, if 4m plus 3 equals to 0, 4m equals to minus 3, m equals to minus 3 by 4, or m equals to 24, m equals to 7, m equals to 7 by 24. Therefore, these are the two values that we get for m. So, now we have the point. Actually, how much we get earlier? 22 comma minus 4. We have a point and we have a slope. Case 1. Case 1. So, m equals to minus 3 by 4. M equals to minus 3 by 4 and P is equals to how much? 22 comma minus 4. So, we have a point and a slope. So, slope point formula. The equation of the direct common tangent, which is having slope m equals to minus 3 by 4 and having, and is passing through 22 comma minus 4. Let us suppose this to be x1, y1. So, y minus y1 equals to m into x minus x1. So, this is equals to y minus of minus 4. So, y plus 4. M is minus 3 by 4 into x minus x1, 22. This is equals to 4 into y, 4y, 4 4s are 16, minus 3x, minus into minus plus, 3, 22, 66. Therefore, 3x, if I transpose, plus 4y, plus 16 minus 66. So, minus 50 equals to 0. this is one direct common tangent, any one of the direct common tangent. And for getting the second, case 2. So m equals to this time 7 by 24 we have to take into consideration, and point is as usual. So 5 minus y1 minus of minus plus m 7 by 24 into x minus x1 22, that is equals to 24y, 24 4s 96, 7x minus 154. So this is equals to 7x minus 24y minus 154 minus 96. So minus 250 is equals to 0. So therefore, the two direct common tangents are 3x plus 4y minus 50 equals to 0 and 7x minus 24y minus 250 equals to 0. So therefore, the direct common tangents are 3x plus 4y minus 50 equals to 0, comma 7x minus 24y minus 250 equals to 0. Now the fourth question is, find the transverse common tangents to the circles given. So the difference between the last problem to that of this problem is, last problem we are asked to find out the direct common tangents. This time transverse common tangents. So I'll tell you again. So the direct common tangent is the line. If two circles lie on the same side of the line, then that line is said to be the direct common tangents. So last problem, this one line and this one line. So as far as if you take this line, with respect to this line, the two circles lie on the same side. Otherwise, another line if you take like this, so this line, these two circles lie on the same side, above side. But this time, what is the transverse common tangent? I don't know whether the two circles position is like this or not. Soon we will get it. Okay, we have the various conditions of the relative position of the two circles. Let us suppose the two circles like this. Earlier, the direct common tangents are these two. This time, transverse common tangent is this or these two. What are the transverse common tangents? Transverse common tangent. So, if the two circles lie on the either side, for example, if I take this line, and this is first circle and this is second circle. Okay. So, these two circles lie on the either side, opposite side of this line, then that line is said to be the transverse common tangent. And the point of intersection of two direct common tangents is the external center of similitude. Last time we get here the point of intersection. Now transverse common tangents point of intersection is internal center of similitude. To obtain the internal center of similitude, R1x2 plus R2x1 by R1 plus R2, R1y2 plus R2y1 by R1 plus R2. External center of similitude is R1x2 minus R2x1 by R1 minus R2, R1y2 minus R2y1 by R1 minus R2. Okay. So, solution, let the given circles be, let us take S, x square plus y square minus 4x minus 10y plus 28 equals to 0, S dash x square plus y square plus 4x minus 6y plus 4 equals to 0. So, the center of the first circle is C1, 2, 5. the radius is R1 equals to 2 square 4, 5 square 25 minus 28. So root of 29 minus 28 is which is 1. C2 is equals to minus 2 comma 3. R2 is equals to 2 square 4, 3 square 9 minus 4. 4 gets cancelled. Root 9 value is 3. And now what is C1 C2? C1 C2 is the distance between 2 points. So the line joining of the two centers of the circle C1 C2 is 2 minus of minus 2 plus 2 whole square plus 5 minus 3 whole square. This is equals to 2 plus 2 is 4 square 16 plus 5 minus 3 2 square which is 4. So root 20 is approximately 4 point something. 4 point something. I'm not concerned about the particular exact value of root 20. So root 16 is 4, root 20 is something more than 4, right? And what is R1 plus R2? R1 plus R2 is 3 plus 1 which is 4. Therefore, what we understand is C1 C2 is greater than R1 plus R2. So then the two circles positions will be, the relative position of the two circles will be like this. One circle lies completely outside the circle. Okay, they neither touches nor intersect each other. Now, see, we are required to find out the transverse common tangent, right? So transverse common tangent means whenever transverse common tangent is there, so there is the existence, there exists a internal center of similitude. So let Q be the point of intersection of two transverse common tangents. So Q is equals to, what is Q? Q is the internal center of similitude of the line joining of the two centers C1, C2. Q is the internal center of similitude. So Q is equals to R1 x2 plus R2 x1 by R1 plus R2, R1 y2 plus R2 y1 by R1 plus R2. Okay, last problem. Two circles are like this. Last time also the condition is same, C1 C2 is greater than R1 plus R2. That time we are required to find out the direct common tangents. Those are this as well as this. So these two are meeting, intersecting at this point. I supposed it to P last problem. So this is C1, C2. So the line joining of the center C1, C2, next the point of intersection of the direct common tangents, external center of similitude, and the point of intersection of the transverse common tangent, external center of similitude, internal center of similitude, all are collinear points. The last problem, we found this to obtain the direct common tangents. This problem, we are finding Q, which is the internal center of similitude. As far as P was concerned, it was R1 x2. Remember, R1 x2 minus R2 x1 by R1 minus R2, comma R1 y2 minus R2 y1 by R1 minus R2. This time, this, that means this point of intersection I want. What is this point of intersection? This point of intersection is the result of the point of intersection of two transverse common tangents, and that is Q. For this Q, R1 x2 plus R2 x1 by R1 plus R2, comma R1 y2 plus R2 y1 by R1 plus R2. So let us find this. Okay. Now, okay. So this Q is equals to R1 x2. See here, this is x1, y1, x2, y2. R1 x2 is 1 into minus 2, minus 2. 1 into minus 2 plus R2 x1 3 into 2 6 by R1 plus R2 3 plus 1 4, comma R1 y2 1 into 3 3 plus R2 y1 3 into 5 3 5s are 18 by R1 plus R2 is 4. So answer is 6 minus 2 4 by 4 1, comma 3 plus 18 21 by 4, this is 9 by 2. So what is this Q? This Q value is 1 comma 9 by 2. Now what do we require to find the transverse common tangents? Let M be the slope of the required transverse common tangents. Okay, required transverse common tangent. Since these transverse common tangents, are passing through which point? Q. Because transverse common tangent is passing through the internal center of similitude, because internal center of similitude is the point of intersection of two transverse common tangents. So through Q. What is Q? 1 comma 9 by 2. Therefore we have the slope M and point. So what is the equation of a line which is having a slope M and the point x1 y1? Y minus. So equation of the transverse common tangent is y minus y1 is equals to M into x minus x1. So y minus, what is y1? 9 by 2 is equals to M into x minus x1 is 1. So find out the LCM. So 2y minus 9 by 2 is equals to mx minus m. So therefore 2mx minus 2y 2mx minus 2y minus 2m plus 9 equals to 0. Let us suppose this to be the first equation. So the equation of the transverse common tangent is this, we get. Okay. Now since it may be one of these two, we don't know exactly as which represents. Okay, which represents this line, either this or this. Okay, and since this line, this tangent touches, or to be more specific, this line touches. Okay, since this line 1 touches both the circles 1 and 2, both the circles S equals to 0 comma S dash equals to 0. So what is the tangential condition? When a line touches the circle, R equals to D. Radius is equals to perpendicular distance from the center of one of these circles to the line that we get. Okay, so R equals to D. So the radius of the first circle is 1 is equals to D is the perpendicular distance from the center of the circle, first circle 2, 5 to this line. So perpendicular distance is 2m into x is 2 minus 2 into y value is 5 plus 9 minus 2m by square root of 2m whole square 4m square plus minus 2 whole square is plus 4. So radius of the first circle, since this line, this transverse common tangent, this line touches the first circle. Otherwise, actually, this line touches the second circle as well. If you want to apply the tangential condition R equals to D, the radius of the first circle is equals to the perpendicular distance from the center of the first circle to the line. Or you may even apply the same rule for the second circle as well, because the transverse common tangent is also the line touches the second circle. In that case, the radius and center should be taken the second circles. Okay, the center and radius of the second circle is to be taken into account. Okay, so now 1 is equals to 2 to the 4m minus 2m, which is 2m, minus 2 5 is 10 plus 9, so which is minus 1 by square root of 4m square plus 4. So cross multiplication and squaring on both sides. Cross multiplication and squaring on both sides gives us 4m square plus 4 is equals to 2m minus 1 whole square, 4m square plus 1 minus 4m. So this is equals to, you simply have to divide. So this is 4m square is equals to 4m square. 1 minus 4 is minus 3 minus 4m. So dividing by m square on both sides. Then 4m square by m square. Otherwise 4m square. Otherwise you may apply the same thing. So 4m square gets cancelled. So this is 3 is equals to minus 4m. Therefore, m is equals to minus 3 by 4. Since this is the line, this is the quadratic equation in terms of m. M square means m should get the two values, but only one value we get. The second value will be infinity. So since the second value is not existing here, equals to infinity, it is a vertical line. So now equation of the required transverse common tangent, equation of the required common tangent having slope m equals to minus 3 by 4 and passing through, so this being the transverse common tangent, it must pass through the internal center of similitude, which 1 comma 9 by 2. Passing through Q 1 comma 9 by 2 is y minus y1 9 by 2 is equals to m minus 3 by 4 into x minus 1. So this is 2y minus 9 by 2 is equals to minus 3 by 4 into x minus 1. This 2 times. So 2 2s are 4y, 2 9s are 18, minus 3x, minus into minus plus 3. Therefore, 3x plus 4y minus 18 minus 3 is minus 21 equals to 0. But this is not the only answer. So m equals to infinity also we get. So this is case 1, case 2 now. This is case 1. Why case 1? Because this line has got two slopes. It must have two slopes. For that is why actually we are getting the two transverse common tangent. One transverse common tangent slope we get minus 3 by 4. Therefore, this is the line. This is the one of the transverse common tangent. The second transverse common tangent slope is infinity. So, if m equals to infinity, that m equals to infinity means what? This, the slope is infinity. That means it is a vertical line. So, what is the equation of the vertical line? Equation of the vertical line having slope m equals to infinity and passing through 1 comma 9 by 2 is, what is the equation of the vertical line? X equals to k. So x equals to what is k? 1. So if you do not know, that is x minus 1 equals to 0. Okay. So if we are struggling, sir, what is this vertical line and all, then actually you may take like this, y minus 9 by 2 equals to minus 3 by 4. Infinity means 1 by 0, right? Into x minus 1. 1 by 0, you cross multiply 0 into something 0, 1 into x minus 1, therefore x equals to 1. Therefore, the equations of the required transverse common tangents are x minus 1 equals to 0, comma 3x plus 4y minus 21 equals to 0. These two problems are very much important as far as the Board of Intermediate Education papers are concerned. So these are the questions that were repeatedly asked in the examination. So the next question is, find the pair of tangents from 4, 0 to the circle. We have already derived this theorem also. So what is that is given is, this is the circle that is given. This is s equals to 0. This is the point P, which is x1 y1 is 4, 0. x1 y1. So the pair of tangents from this point to the circle, that means, so the two pair of tangents will be like this. Okay, two pair of tangents will be like this. So the combined pair of tangents from the point P x1 y1 to the circle s is equals to 0 is what? S1 square is equals to s into s11. So this is the combined pair of tangents we are getting, to s1 square equals to s into s11. So what is s1? xx1 plus yy1 minus 25. S means this circle. S11 is simply substituting x1 y1 point in this, x1 square plus y1 square minus 21. I am telling you, so if I substitute this point and circle in this, then this is the pair of tangents, the combined pair of tangents we are getting. So remember, the last year we have studied ax square plus 2hxy plus by square equals to 0, second degree homogeneous equation. That is the equation, that is the combined equation passing through the center of the circle. So while solving the problem, while solving the theorem, while deriving the theorem, the separate line equations L1x plus M1y equals to 0, L2x plus M2y equals to 0 is what we have to take. Yes. And for ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, this is the second degree non-homogeneous equation. That is the combined equation of the lines not passing through the origin. So the individual equations, if we want, then it will be L1x plus M1y plus N1 equals to 0, extra N1 equals to 0, L2x plus M2y plus N2 equals to 0. So the thing which is different from the first one is L1x plus M1y equals to 0, L2x plus M2y equals to 0. Here plus N1 equals to 0, plus N2 equals to 0. So that is the combined pair of tangents, that is this. So if you want the separate line equations, then whatever that we have discussed for pair of transverse common tangents and direct common tangents, the last two problems, those are the individual lines. If you want the total lines, then it will be this combined pair of tangents. So find the pair of tangents from 0, 0 to the circle x square plus y square plus 10x plus 10y plus 40 equals to 0. That means the circle is given like this and the point is P 0, 0 this time. So these are the combined pair of tangents. So the combined pair of tangents equation is S1 square equals to S into S11. So what is S1 square? XX1 plus YY1 plus 5 into X plus X1 plus 5 into Y plus Y1 plus 40 whole square is equals to S into S11. So X square plus Y square plus 10X plus 10Y plus 40 into S11 X1 square plus Y1 square plus 10X1 plus 10Y1 plus 40 equals 40. So since the point is X1, Y1 is 0, 0, 0, 0 is X1, Y1. So 0 into X1, X into 0, Y into 0. So 5 into X plus 0 is 5X. 5 into Y plus 0 is 5Y plus 40 whole square is equals to X square plus Y square plus 10X plus 10Y plus 40 into this is 0 square, 0 square, 10 zeros, 10 y, so 40 this is equals to, if I take 5 in common here, X plus Y plus 5 8s are 40 whole square. So whole square means 5 square 25. So this is 25 into X plus Y plus 8 whole square. Okay. So this is equals to 40 into X square plus Y square plus 10X plus 10Y plus 40. So 5 3s, 5 5s are 5 8s are. So this is 5 into A plus B plus C whole square, A square plus B square plus C square plus 2XY plus 2 8 is 16Y plus 16X is equals to 8X square plus 8Y square plus 80X plus 80Y plus 320 840s. Therefore, 8x square minus 5x square, which is 3x square, plus this is 5 2s are 10xy. If I transpose that side, that is minus 10xy plus 5 into y square, 5y square, 8y square minus 5y square is plus 3y square. Next, 5 16s, 5 16s, 16 5s, 80. This 5 16s 80x, 80x gets cancelled, and 5 16y is 80y. That 80y, this 80y gets cancelled, and 564s, 564s, 320, 320, and this 320 gets cancelled, is equals to 0. So this is the pair of tangents. See, last year, ax square, this is of the form ax square plus 2hxy plus by square equals to 0. This is the second degree homogeneous equation. Okay, second degree homogeneous equation. That is the combined equation of the pair of lines passing through the origin 0, 0. That is why last year L1x plus M1y equals to 0, L2x plus M2y equals to 0 is what we have taken into account while proving the theorem. So same, this is the combined pair of tangents. See, this is the combined pair of the tangents passing through the origin. Okay, so this is the combined. So if we solve, for example, then actually you will be getting the two lines passing through the origin. What are they? L1x plus M1y plus constant N1 equals to 0. Constant will be missing. Okay, so this is the final answer.